Hello everyone, Vasseei here. Hope all of you are doing well. This is your 7.3 video. I want to start this out by apologizing ahead of time. I can't put this in landscape view and my iPad's not working, so the video quality might not be optimal here. We're just gonna have to make do. That's it for beginning stuff. Let's just go ahead and start. To review, last video you learned about a new format for equations and a new equation type called an exponential equation. It's y equals a times b to the x. That's the format for them. Y represents the dependent variable still. A is the initial value instead of b, the way it is for linears. And b now acts like your slope did with linears. B controls the growth or decay rate of your outputs, and x is now in the exponent spot. It represents the number of compoundings that occur. And one thing I kind of noticed when I watched the last video is I didn't do a very good job of explaining what the heck a compounding is. All that is the length of time it takes for your dependent variable to double or to triple or to get cut by a half. And it's basically what you're going to actually plug into your equation to get whatever value you're seeking. Okay. All right. Done with the review. Now for the new stuff. Okay. We're just going to kind of dive into an example and identify the new part of this problem and how to handle it. It's just one slight variation that changes. Everything else is basically the same as what you saw in the last video. So we have a guy named Hank whose business is projected to increase in value by 1.2% every 9 months. It's worth $80,000 now, and we're trying to figure out how much it'll be worth in 5 years. So this is still going to be a y equals a times b to the x, and I'm going to fill in the parts that I do know how to fill in. I know y is going to be the business value. I know A is going to be 80 grand. I have no idea what B is, at least right now, because I wasn't told the word double or triple or cut by a half. That normally is my clue that I look for. So we'll leave B alone for now. And I'm going to go ahead and attack X. I know X is always equal to total time, which is 5 years, divided by the length of one compounding, which is 9 months. And I'm realizing now that this is not going to make the problem nice, because I think this is going to give me crappy numbers. It might not. If it does, I'm going to switch it because I don't want to deal with those. Yeah. Anyway, from here we're going to have to convert units because we can't take 5 years and divide by 9 months. So let's change the years to months. 12 months in a year means 60 months in 5 years. And let's see if that divides out to a nice number. I think I have a way to get my calculator to show up for you guys. 60 divided by 9 gives me that, which I don't like. We're gonna keep it as a fraction. I'm gonna show you how to type that into your calculator in just a sec. Okay, so we're gonna keep this as 60 over 9. Okay. All right, now let's get B. This is the new part, so pay attention here. If your growth rate is a percent, then the way you express your B value is you start with 1, because you're gonna get 100% of your initial quantity back, okay? But you're also gonna get something a little bit extra. In this case, an extra 1.2% every time a compounding occurs. So every time you compound, you're essentially multiplying by 1 plus 0.012. All right, and so the way we set this up now is y will equal 80,000 times 1 plus 0.012 in parentheses. That's the other new thing. If you want to just add these quantities together in your head so that you don't have to have a sum here and can avoid the parentheses, feel free. That'll work. Okay. And then the way you're going to express this value, a fraction, is on your calculator. You're going to hit that upwards arrow key, and then in parentheses, you're going to put 60 divided by 9. Okay. And I'm going to type that up on my calculator really quick so you can see it. There we go. Put that on the screen. This is what your calculator should look like. Okay, when you hit enter, yep. One sec. There we go. This is what you should get. All right, next one. All right, we have a car whose value is expected to decrease by 2% every 2 years, and we're going to figure out how much it's worth in 10 years. If it's worth $18,500 right now. Okay, so again, I'm going to fill in the parts that I do know how to do. I know Y is the car's value. There we go. The initial value is 18,500, and I know X is going to be 10 years divided by 2 years, which is 5. Okay. Now, my growth rate is indicated by this portion of the prompt right here, decreased by 2%, which means my B is going to be 1 minus 0.02. Because every time I compound, I'm starting with 100% of my value, and I'm losing 2%. So, the way the equation looks is y equals 18,500 times 1 minus 0.02, and that's going to be raised to the 5th power. Because it's going to decrease by 2% 5 times over the course of that 10-year period. Okay, and then from here, you just type everything in. So give me 1 sec. This is what it should look like on your calculator. And this is what your answer should be. And that is all for the video. I hope this finds you well, and all of you are doing okay. That is all from me. Vasseei out.